All right, here's how we can use the Desmos online graphing calculator to use a linear regression to find a line of best fit for a set of data. So when I go to Desmos.com, I'm going to go ahead and go right here to start graphing. When I do that, I see I've got my graph, and you can play around with this. You can type in anything you want. Y equals 3x plus 5. And ta-da, there's the line 3x plus 5. We don't want that though. What I want instead is I want to be able to enter a set of data. I'm going to do the same data that we just did about femur length and about a person's height. So I'm going to go here to this plus where it says to add an item. And I'm going to pull this down. And because I'm going to put in data, I want to add a table. And it'll look like this. Okay? Notice that it's calling this x1 and y1. That's going to be important. Every so often, it might name it something different. Like it might think that you'd used it before or whatever. If it says Y2, you have to watch out for that, and I'll show you why in just a second. So let's see, where was my data set? Here it is. This was the data that we were working with. So I'm going to go ahead and put that into my table. So I have 40, 45. I'm going to go ahead and do that, and then I'm going to put in all of the y's, and it'll look something like this. Ta-da! All my data. Okay, now, you'll notice nothing happened. If I look over here at my graph, I don't see anything at all. That's because our lowest value is like 150 on the y's. I'm only looking at up to 6. So I can zoom in and out by scrolling up and down. So I'm using my trackpad and my 2 fingers to zoom in and out. Ta-da! There it is. So here is my data. This is what we just did. You can also use these plus minus buttons over here to zoom in and out. If you're not sure what I meant by scrolling, you can do that way. So now what we need to do, it's got the data. We need to tell it to write us an equation that uses this data. We can see even better on here than when we graphed it by hand that this data appears to be a pretty strong positive correlation. Okay, that's that R value that we looked at. It's pretty darn close to a straight line. So that is a good sign that a line is going to be a good way to do it. Now here is how you are going to type this in. We need to first tell it what variables to use in our equation. We want it to use the x's and the y's that are here in this table. That's why knowing the name of the columns is so important. I need to make sure that when I type y equals mx plus b, I tell it to use the x1s and I tell it to use the y1s. So here's how we're going to type this. We're going to type just y equals mx plus b because that's the equation I want. So I'm going to type y1. And you see it tells me that's a 10-element list. It knows which data it's looking at, so that's good. Now, I'm not going to put in an equal sign because I want it to figure out. The way I tell it to figure out the equation is right underneath the escape button. You're going to use that little tilde sign, that little squiggle. It's right underneath the escape, and you're going to do like that. Then you just type M, and then we're going to put X, but again, we want it to use the X1s, so just type X1. And then plus B. And you see it automatically draws that line there. I can click this and it'll take those numbers away and I can see more. So look at all of this stuff that it gives us, okay? We only care about a couple of things on here. Looking in this box, okay, here's what I need. I need the parameters because that tells me what the M and the B are. Now, if you look back at the example we did by hand, we came up with a slope of 2.5 and we had a y-intercept of 70. So we weren't quite on because we're not computers, but you can see we were relatively close to what the computer found to be the actual best model. Now, I would say let's go ahead and take at least 2 decimal places. So I want to take these and I want to plug them into y equals mx plus b. So that tells me that the equation of this blue line, based on what the computer says, is going to be y equals 2.603. So I'm just going to leave 2.6x plus, and I know it's addition because b is positive, 64.997. Well, if I round that any kind of way, I'm going to get up to 65. So that seems like kind of a natural place to round it. Y equals 2.6x plus 65. So you can see the line that we got was very close, but it was not exactly perfect. Then the second thing that we can get information from here is that value for R that we talked about, the correlation coefficient. Our R value is 0.995. That tells us that this has a very strong positive correlation. And that's important because that tells us that our line is a good model as opposed to some other type of function, and our data is very, very linear. Alrighty, so those are the steps that you want to follow when you use the computer to come up with this data.